Hey everybody, my name is Milecia McGregor and I am a developer advocate at Conducto, where we build a tool that helps developers make their CI/CD pipelines without YAML and you can debug live. So today I'm gonna talk to you about working with PKCE to communicate with the cloud. So basically we'll talk about this PKCE authorization flow that helps you get to your cloud resources like APIs. And if you're interested in more stuff like this, feel free to follow me on Twitter at Flipped Coding. So before we jump into everything, I want to give you all a quick overview of what we'll be covering. The first thing we'll talk about is what is PKCE. So we'll get into the details of what this auth flow is, what it does, and how it's different from the others. Then we'll talk about why PKCE has replaced the implicit flow to become the new standard for authorization. We'll go over an example implementation of PKCE just so y'all can see how easy it really is to implement this to protect your cloud resources. And then we'll go over a few more auth considerations for the cloud so you make sure everything stays secure. And we'll cover a few other auth flows that don't involve web apps because we do write different kinds of software. So we need to know how to authorize those different apps. And lastly, we will wrap up with the key takeaways. So to get started, we'll go over what is PKCE. So PKCE stands for Proof Key for Code Exchange, and it's the new standard for more secure authorization, which was introduced by auth 2.0. But the main thing that this does differently from the implicit flow is that it establishes that a client actually owns their access token. So what this does, it helps prevent attackers from intercepting their authorization code. What that means is usually when you go through the implicit flow for a web app in particular, you send the credentials, the server validates you get some kind of access token back, and then you use that to make requests to the API or to any other cloud resources. And the problem with that is anybody who can access your computer or even just your browser could look into your cookies or your local storage or any other saved session information and find this access token and use it to authenticate themselves into your cloud resource. So that means you could have somebody with admin level access using your APIs to do some kind of malicious attack for all of your users. And that's what PKCE is here to help prevent. So this became the new OAuth standard after a few really major holes were found in the implicit flow. But the way that PKCE handles things that's different from the implicit flow is first, of course, the user clicks on login link, but the app itself generates this code verifier, which is just a string. It can be a SHA encoded string, it can be a plain text string. Either way, the client has this code verifier, which is typically a SHA string, and it is sent along with the authorization request. Then there's also the code challenge, which is created from the code verifier, and it's sent in the authorization request, but it's also used to verify the code verifier later in this flow. And pretty much what it does is it's made by hashing the code verifier. But if you don't want to hash the code verifier, you can just use the code verifier as the code challenge. It's just a way to have the client with some kind of information that only it would know about the authorization request. There's also an optional parameter called the code challenge method, and this can be what's used to make the code challenge. Basically, you can specify if the code challenge should be a SHA string or if it should just be plain text. If you don't put anything in for the code challenge method, then it's probably just going to be a plain text, and that's fine. But that's what's happening here at this code verifier code challenge phase. Then, of course, things get sent to your auth entity. You get some login redirects sent to the user so they put in their credentials. After they put in their credentials, they either authenticate and you authorize them, all that good stuff. This is where the other part of PKCE comes in and makes things super secure. That authorization code has to have the code verifier as well. Without that code verifier, the person trying to log in will not get through the auth flow. They'll just be returned to the login page or whatever other kind of setup you have for them. But if they do have a code verifier included, then you validate this code verifier and the challenge in your auth entity, and if things check out, you send the access token. So basically what happens that's different from the implicit flow is that this code verifier and code challenge live on the app as well as the server. So if somebody does intercept the access token anywhere in this, then they won't be able to authenticate because they don't have the client side code verifier to match the server. And that's how PKCE makes our apps more secure. That's how it protects all of our cloud resources, API calls, and everything else. And we've talked about some of the reasons it has replaced implicit flow, but it's worth reiterating. Your authorization token can be stolen in an interception attack. And basically what that is when an attacker comes and they get your access token somehow and they use it to log into an application pretending it's you without ever having to enter any credentials. Once you have the access token, you have access to the cloud. And then PKCE fixes this because it adds that code verifier and the code challenge to the client as well as the authorization on the back end. And this builds on top of the standard authorization code flow, so that might be why it looked pretty familiar, except for the few things that it added. The authorization code flow is basically the implicit flow, and it was the standard for a really long time. And until recently, it was fine, but we found out that since the client session stuff is stored on mobile devices, is stored in browsers, so that makes it a security weakness. And to fix that, PKCE has come through and replaced it. And again, remember, the only difference, really the only main difference between PKCE and the implicit flow is adding that SHA code verifier, some kind of code challenge, and then the method that you want to use to make the code challenge. So remember, the code challenge method is optional, and if you don't include anything, I think it's just plain text instead of SHA, which doesn't make a difference, it's no big deal. And then the code verifier is the thing that is on the client as well as the server, and the code challenge is what verifies that those are the same things. And that is why and how PKCE has replaced implicit flow. So now we'll just look at a quick example of how to implement PKCE. It's actually really easy if you're using some kind of auth entity like auth. Like them in particular, they have a library that you can just use this hook, and basically it will tell you if a user has been authenticated. It'll automatically pop up a login, so when somebody tries to sign into your app, they're just taken to the auth login form. And then when somebody logs out, there's a method you call so that auth clears out any credentials or cookies or any other session info that could possibly be used in an attack. So with these this one parameter and these two methods, all you have to do is just add them to your code. So basically what we've set up here, this is just a little budget tracker app that I made for this demo. And what you have is just a login button. So when a user comes to the page, they click the button, and if they have not been authenticated yet, then the login pop-up for auth will show and they enter their credentials. But if they have been logged in, they won't see the login button, but they'll see this logout button, and when you click it, they should be returned to our local host. So that's actually it. In a React app, that is how you implement PKCE. So basically that just means go choose the right auth provider for you and hook into their methods. Or if you really need to make a custom authentication flow, you want to really consider spinning up your own separate service and not including that in the application itself, just so that you can reuse it amongst other apps that you're working on. But I'll go ahead and run this just so that you can have an idea of what this auth flow looks like, which honestly you've seen it 1,000 times just because it's an auth flow. So we'll wait for the app to come up. Just want to make sure I don't have any weird build errors going on. Okay, so it automatically takes me to this auth login page, and I'll just go ahead and sign in with one of my Google accounts. So we'll sign in, and ta-da! As you can see, there is a logout button, and so far I haven't spent any money this month. That's really good. But back to the code, you see that means we have used this is authenticated parameter to determine which button to show and what actions to take. We've logged in with the auth pop-up, and we're about to use the logout just so that it cleans up everything. So we log out. Well, I guess there's something weird with it redirecting to localhost, so we'll just skip that part. But basically you see how it works. You just use the methods that come from whatever auth provider you're using, and it's pretty much that easy. Again, if you're trying to implement your own PKCE flow, make sure you create a separate service so that not only can you use it across other projects, but you can update it and keep it in compliance with the current web security standards. So now that you know how to implement PKCE, which hopefully you see is really easy, and it gives you access to your cloud resources, no problem. It all happens behind the scenes. So as long as you aren't trying to change it too much, it's a really straightforward auth flow to implement. But there are some more considerations for authorization in the cloud. So you want to make sure that you're keeping your user permissions up to date. There have been times where old employees still have admin level access to pretty much everything. There are times where new employees don't have enough access. So make sure that your users have the correct permissions. Nobody should be able to access anything that you aren't expecting them to. And then make sure that all of your credentials and secrets are encrypted and kept really safe. One thing that is a common security flaw for cloud resources is that people don't update usernames and passwords, or they leave old username and passwords that a lot of people know, and that creates just really big security holes. So you don't want to have some spreadsheet that you email between your coworkers with all of your login credentials, of course. But if you can, try to store any of these things in your CI/CD pipelines or on your auth provider specifically, or in something like OnePass. Whatever you're doing, make sure that you keep all of your credentials and secrets for these cloud resources secure and hopefully encrypted. I know that you can have your code verifier and code challenge as plain text, but do not store your credentials and secrets as plain text ever. And then something else to consider when you're working with the cloud. Make sure you know what kind of app you're working with. In a lot of cases, we think about things just from a web app perspective, but remember there are other software engineers working on things like IoT devices, or they're working on software where machines just communicate with each other with no human user. So those will have different authorization flows than a regular web app. And that's why you need to make sure you know what you're approaching before you choose an auth flow. And something else, especially for the cloud and web apps, is make sure that when you make these JWTs, you aren't adding unnecessary information. So if your API response has changed or the request parameters have changed, make sure that whatever is in that token is the bare minimum of what's needed to access that cloud resource. So if you have some leftover user IDs or some leftover general user information, make sure that you're updating that and adding things as you need them, but please make sure you're removing things as well. Those JWTs can be decrypted by free online websites. So you don't want to have any plain text secrets or anything else you just don't want people to have access to or still have access to. And we briefly mentioned the other auth flows that software developers might face. And one that we'll talk about real quick, just so you know where PKCE comes from, is the authorization code flow. So this is the original standard for verifying a user's access to a web app. And basically they go through the same flow. They click some login button, they send some kind of request to authorize, and they get redirected to some kind of login. They put in their credentials, the auth provider will either validate them or not, and then they get an access token. So once they have the access token, they can do whatever they want with your API or with your images that are in the cloud, whatever cloud resource you're giving them permission to access. That's why PKCE came along, because this flow has just a few security holes that make it too easy for hackers to get access to those cloud resources. Another authorization flow is the client credentials flow. And basically what this is, it's a way for machines that communicate with each other to authenticate each other and make sure that it's the right device communicating to the right device. And the way that these work is that each machine has their own client ID and secret, and the auth provider is going to be able to verify those before it sends any type of access token to the machine. But once those things are verified, the machine gets the token and it can communicate with the API, the cloud, or any of the other machines that it's connected to in this way. But in most cases, it'll probably get some kind of response from another machine, or it'll send a response to another machine. Then another flow that you probably have used a lot this year, just because of how 2020 has been, is the device flow. So all of those IoT devices, your smartwatch, your Ring doorbell cameras, your thermostat adjusters that you have on your phone, pretty much everything that you can control via an app will fall under this authorization flow. And the way it works is that a user just opens an app, just like you would for like the Ring app or something, and you send the request to log in. So you get some kind of URL redirection or some kind of code that comes to you, and you enter that into whatever login screen it pops up. So once you get past that part of the authorization, some like the access token will go back to your auth provider, and it'll figure out if the device that's trying to connect to the service is actually authorized to connect to the service. So that user code is used more as an indicator of, hey, this device can be used with this service. But once it figures out if your device is good to go, then you get to log in, and this is usually through some kind of web browser or some kind of in-app pop-up. Something will show where you need to enter your credentials. Once you enter those credentials, the auth provider will either verify them or reject them. And if you do get verified, you get the access token, and you can finally use your device. So what's happening there is that at the end of the process, after you've logged in, instead of communicating maybe with an API, maybe it is an API, maybe it's some other resource, but you can send commands to the specific IoT device. Like you can tell your light to turn on from your computer, or you can turn your house alarm off from your phone, things like that. That's what the device authorization flow is for. So now that you know about all of these authorization flows and you've learned a little bit about how to implement PKCE, there's just a few things to go over before we wrap up, and you can start going to use auth for your PKCE in React. But basically, you really want to make sure that you stay up to date with the OAuth standards. They are kind of like the governing body for web security and authorization flows. So make sure that you know about any changes that they're making or any vulnerabilities or weaknesses that they found. Another resource that's good is also the OWASP Top 10. They showed the top 10 web security issues that are just around and you need to be aware of, especially if you're working on web apps. So make sure you know what the latest authorization standards are. And then make sure that you're choosing the right kind of auth flow for your process. So just like we discussed previously, if you're working on an IoT application, you probably don't want to use PKCE because that means somebody else is going to have to log in as a verified device. And that's just not how it works. So make sure that you know what flow is going to work best for your software. And then again, make sure that your users have the right authorization levels. You don't want to give a customer admin level access if you don't want them to see certain features or you don't want them to be able to do certain things. Just make sure that you know who has permission to access which resources on the cloud, who has permission to make changes, and things like that. Because the cloud is where usually the heart of your business is. You don't want someone to mess with that if they aren't supposed to. You don't want unauthorized access. And that's why we go through all of the complicated setup to get this authorization in place. And the last thing that a lot of people actually leave out when they're coming up with the authorization flow is try to think about it from a hacker's point of view. Look at it for any weaknesses that maybe you would try to exploit, or start looking at some of the hacker blogs to see what tools they're using. There's so many ways to attack a user session that you want to make sure whatever auth flow you choose is able to handle it. So we know that PKCE won't let a hacker do authentication injection. Like, it won't let them do that attack. It prevents it just by having that code verifier and that code challenge. So you might think of other ways to try to hack it, like trying to take the code verifier and code challenge and inject it some other way. Or for machine to machine communication, you might try to spoof a client ID and send a bad command to a different machine. Or maybe you try to hack somebody's house and turn up their thermostats just by finding out what device IDs they have authorized. So before you even start to implement your auth flow, make sure you have some kind of threat model in place as well, because that'll help you figure out how you're going to approach implementing that auth flow. So I really hope that this talk helped you figure out how PKCE works and some more about how to include authorization to protect your cloud resources. You never want those to get hacked because that's where all of your data is. So if you want more information, you can follow me on Twitter at Flipped Coding, and I can send you more links to different OAuth stuff, or you can ask me questions about how to set up a custom PKCE flow. Honestly, setting up a custom PKCE flow isn't as bad as you would think, just because everything you do involves strings. No matter what programming language you're using, a custom PKCE flow is basically just a string verifier. So if you can implement that in a way that matches the flow you have in mind, or you want to add an extra layer to the PKCE flow, definitely making your own custom authorization flow based on it is a good way to go. But you definitely need to have the basic PKCE auth steps in place. As long as you have those, you should be fine. So if you have any questions, feel free to ask me, or you can just DM me on Twitter. Thanks for listening, and I really hope that this was useful for you.